This is lab number 3, the pick and place machine. So this is the lab document for it, listing all this stuff here. This is what our machine looks like. So we have the one pick and place 2-axis gantry. So it goes up and down in the Z direction, back and forth in the X direction, and it has a gripper on the end. We're going to have parts that come in down this conveyor. We pick them up, transfer them over to this conveyor, and they transfer out. So we're going to program all of that. Things that we are given. All of the clear conditions are stated for us right here. So we have conditions for the entry and exit conveyors to define what means that they are clear. The P&P, which stands for pick and place. X, advance and return. We have those. The Z direction, raise and lower. We have those. And the gripper, open and lower. Those are all specified to us as well. We also have, for auto mode, we have a cycle chart that defines how the machine should actually cycle in auto. So if you're building a machine, this is typically what you'll get from the mechanical designers. They will provide something like this for you, and this is what you're supposed to program to. In addition to that, I've made a summary table here of what you would expect to see from all of your machine status signals at each step here. So when you actually go to do the pick and place lower, what is the status of everything else at that time? So this will help you define what it is that's going to drive your auto sequence. So this will be helpful when we go to do that. We're also going to define the all home logic. We'll talk about all home and what that does, and we'll program that in there. We are also going to program a part count and a cycle timer in here as well. Alright, so that is all going to happen. And this is how it's going to be marked. And this one we are actually going to submit to Blackboard as well. So part 1, 2, 3, and 4, and then submit to Blackboard. Alright, so that will be our task. So let's go through and get started on this. So I'm going to open up our program. You'll see the program is pretty complete for you. We have our map inputs. Map inputs is pretty much defined already. One thing you'll notice this week, when we have our P&P X advance and return proxies, we don't have proximity switches, if you remember, on the gantry, because it gives a numeric position for us. But what we do have is that numeric position that comes in as a floating point number, and that number ranges between 0 and 10. So when we are in the advanced position, we read about 10 on that number. So we are actually going to use a limit instruction and say that if we have a value that is between 9.9 and 10, which comes on when you're pretty much all the way advanced, we'll say that that is basically defining the advanced position. Likewise, we're going to say that if we are between 0 and 0.2, that will define our return position. We're going to do the same thing on the Z direction as well. We'll say if we are between 0 and 1, that is going to define the raised position. And if we are between 9 and 10, that will define our lowered position. Okay, so that is a little bit of a difference there. as we don't have regular proximity switches for that. Everything else works pretty similar. And we will move right along into this here. So let's get going. So let's start with the conveyors. So we're going to go through and define all of our clear conditions first. So let's start looking at our conveyor logic. So this says, for our entry conveyor, the part should not be able to roll off the end of the conveyor, and a new part should not be able to convey in and collide with a part that is being picked up or hit the pick in place. So how would we define those two things? So parts should not be able to roll off the end of the conveyor. So I think what we're saying here is we want to make sure, so there's two different conditions here. We want to make sure that PP at entry conveyor, we're not allowed to have part present at the entry conveyor and still be clear. We can't do that. I'm just going to put a comment on here because the comment is missing. Part present at pickup position. And then the other thing here, new part should not be able to convey in and collide with a part that's being picked up or the pick in place. And so I will say this can only convey when we are raised or not returned. So if the raise complete is good, that means we're actually in the raise position. Or if we are not returned. So that's P&P, x-axis, return complete. So if we're raised, we're clear, or if we're not at the return position, we're clear. Either of those. And we can't have a part at the entry, at the pickup position. Either of those should be good. Okay, so I think that satisfies those conditions there. Let's look at the exit conveyor. Conveyor should not be running when a new part is being dropped off. Alright, so when is a new part being dropped off? I would say that is whenever we are in the advanced position. So why don't we call this P and PX is in the advanced position. Alright, I'm happy with that. Let's look at the X over here. So here we have our advanced fault, and what else can we put in here? Make sure you can't crash into the photo eyes. So what does that mean? That means basically we want to make sure we don't hit these photo eyes. So that means make sure we are actually, up in the raised position when we're traveling back and forth. So only advance and return when we're raised. That's what both of these mean here. So we're going to say that P&P has to be raised. Raise complete. And that is the same thing for the return motion. So let's do that. How about the Z motion? So we're going to say raise, no special conditions there on the raise. We can't hit anything there. How about the lower? Don't place a part on top of another part. So for the lower, we are not going to lower if there's already a part there. So don't lower if there's a part present at the exit. And only lower when you're over top of one of the conveyors. So that is basically saying we are in either the raised or either the advanced or returned condition positions. So at one end or the other. So P&P X is either advanced complete or return complete. That will satisfy that condition there. And when can we open and close the gripper? Closing the gripper, nothing special. Opening the gripper, don't open the gripper if there is a part in it unless you are in position to drop off the part. So we're allowed to open if we don't have a part. So gripper part present. So we don't have a gripper part present, we can open. Or if we're in position to drop, which basically means we are P&P X advanced and P&P Y, or sorry, P&P Z lowered. In that case, we'd be allowed to open. So that should be it there. So that basically takes care of all of our clear conditions. Alright, so that should be good there. Let's go through, actually download this. we will download and test. Alright, let's see this thing run. So we are downloaded. We are connected. Let's put this thing in cycle. So if we put it in manual mode and give it a try, so what we should see now is we can jog that conveyor. I can drop that down. If I drop that down, I should not be able to jog the conveyor anymore, and I can't. I can do it if it's up. If I move that over there and lower it, I can jog then. Now, if I jog, once I get into the photo eye, it should stop and not let me jog anymore. I can't move that anymore. And you can see there, I can't return it right now because I can only return when it's raised. So that's good. I can lower. I can't advance when it's like that. I've gripped. I can raise. I cannot ungrip it there. I can move over here. I can't ungrip. I can drop it there. Now I can ungrip. I can do that. I can bring another one in. Interesting, why can't I lower right now? So, part present at the exit. So I should be able to lower the part present at the exit if I'm in the return position. So I'm just going to jump around that with return position is okay. That should allow me to do it there. I will grip, raise, advance. Now this should not let me lower. So I can't lower now. If I move this one out of here, conveyor's not letting me move. Can't move the X conveyor. Now it lets me go. Okay. And there we go. So that's all of our manual motions completed. Let's start looking at auto. So this is our sequence here. So this gives us a whole timeline of how everything should happen. So we want to lower the pick and place, close the gripper, raise, advance, lower, open the gripper, raise, return, bring in the new part, take the old part away. Okay, so we basically want to do that. And we have another chart here that basically shows what the signals are doing at the time. And this is what's going to help us actually program. So those are our steps in order there. So let's go through each of these steps and kind of build up what happens here. So you can see I have the signals just defined as either on or off. Some of them are a question mark here, which means they're not reliable in that state. We really don't know what state they are. So they're not good signals to use at that point. So in order to trigger the lower, so moving in the Z direction to lower, we need to put some logic here. So what does this look like? So at this point, we know that we will be returned, our gripper will be open, we'll have no part present, and there was a part present at the entry conveyor. So we could use all four of those signals, or only the unique portion of this. And when I say the unique portion of it, we might not need all four of those signals. We could use all four, but there might be some that are kind of redundant. So for example, can we have gripper present without gripper present off with the gripper closed? Yes, we probably can. But let's just, for fun, let's actually put all four of these pieces in here. So we are saying that we have PNPX is going to be return complete. Gripper open complete. I'll put a name on there, call it gripper. Let's call this gripper part present. This is going to be off. And let's call this PP at entry conveyor. This is going to be on. There's all those signals, so 4 different signals in there. I'm just going to take a copy of this because we might use these later on as well. So that defines gripper lower. Now here's the trick here. Is there another time where we actually have gripper lower? We look down this list here and we look and we see, oh yes there is. Step number 5 is also gripper lower. So how do we differentiate these two? Well, there's actually some different conditions here for that one. That's when we actually are in the advanced position. Our gripper is closed and our part present is on. We really don't know what's going on at the entry conveyor. We don't care at this point. It could be on, it could be off. So we're not going to worry about that. But we can define what all these other ones should be, because this also should tell the gripper, tell the pick and place to move downwards. So let's look at these signals here again. So for this one, that is the advance complete, the close complete, and the gripper part present is on. That is also doing the lower command. So notice that the raise and the lower both happen twice within this sequence, so it will be a branched line that actually controls that. Alright, so that was pick and place lower. Let's look at gripping the part. That's our next step. We go to the gripper, so closing the gripper. That is going to define as we are lowered, returned, and part present. So that should define that. Let's look here for raise, P&P raise. Let's go back to the Z axis. Again, we're going to have 2 branches on this one. So the 2 different branches here. We know that we are returned, we are clamp closed, and we are part present. Gripper close complete. And then the other raise is going to be advanced, opened, and uncertain on the other signal, so it's really only the 2 that we need. Now P&P advance. Here's our advance motion here. is going to be raised, closed, and gripper part present. And gripper returned. So it's advanced. We've already done this lower. Ungrip the part. Is P&P lower? Advanced. And gripper part on. Raise we've already done. And then our return. This is our final one. And this is going to be raise, opened, and gripper is off. All right, so let's look at these. I'm going to assemble all this logic. And we're going to try this. So, here we go. Switch to auto mode. Start the machine. And as soon as I start the machine, the entry conveyor does not run. Why is that? Because we don't have anything in here. What makes the conveyors run in auto? I think there is nothing. They just run all the time. Entry conveyor and exit conveyor. They're just going to run all the time as long as we are in auto. All right. So this seems to not be lowering until there's a part present over here. So what do we have wrong in there that's causing that? Ah, part present at entry conveyor. That should be inside this. That should only be on that line for the return position, not the advanced position. There we go. So that is running in auto. And what we should now see as well, we should be able to stop this at any time. Throw this thing into manual, switch it back to auto, have it recover. We should be able to do any of those things as well. So that is running in manual and auto. So that is our sequencing pick and place. Okay, so we only had to modify this line. So our clear and our auto conditions sets up everything we need to do to be able to run effectively. Now, the next thing we want to do, all home logic. So all home, the purpose of this is if you stop the machine cycle anywhere, what you want to be able to do is return the machine to its home position. Now, home position in this one is defined as what is the start position for this sequence. So if you look up here, where does this start out from? It basically starts at the raised, returned, and gripper open position. So that is defined as home, which we're defining here. You can see in this line of logic, that defines all home. You'll actually see the light, this all home light come on when we're in that position briefly. So we want to create we have a button that if we go into manual and push that button down, it will bring us back to that position. Now there's two different ways to get there. One would be if we have a part in the gripper at the time. If we have a part in the gripper, we want to complete that cycle and then return to home. If we do not have a part, we just want to go directly there. So we have to be able to handle both of those conditions. So we're going to look at our logic and kind of figure that out. So if we have a part in the gripper, it's going to look kind of like auto. If we do not have a part in the gripper, we're basically going to do that returning motion. So let's look at that and kind of see what we mean by that. So here, we'll just pause this thing. So let's start with the X direction here. So if we are all home in the advance, so if we say all home, and this is modes.allHome, if we get this button while we're in manual, what are we going to do? We are basically going to complete that logic there. So it's basically the doing this logic here. If we are raised and closed and we have a part in the gripper, we will do the advance. If we get all home, and we have no part, we are just going to return, do our return. Okay, let's repeat that for here. Again, if we have a part, this is actually going to require a branch. So if we have a part, we'll do this. You can see this one here actually dictates if we have no part. What will we do? For this one, we really don't. This one doesn't apply because that's going back to pick up another part again. We're not going to do that. We would only lower if we have a part. And when would we raise? So if we got a part in the gripper, we do that. If we're advanced and we're opened, then we would just raise. And with the gripper, how do we handle that? We would open. If we are lowered or advanced and we have part in the gripper, we open. We are never going to actually close, I don't think. Yeah, we won't close for this. To that. So that is complete there. So let's look at this logic and see if it works. So like we just said, what should happen now is when we push the all home button, if we're in manual, if we're partway through cycle, it should drop that part off and just return to its home position. If we have not yet picked up a part, it should just go directly to its home position. So, right now, where are we at? So we're in manual. I should be able to push this button here. And we just bring it back home and we get the green light. So, if I do that, I go all home. That should bring it back. Let's figure out what happened there. So if I'm over here, I say all home, that brings me back. If I'm down here, and I say all home, brings me back. So I basically should be able to stop anywhere like that, and then hold down all home, finish off that cycle, and end up back at home position like this. That is the idea of that. Okay, so that is basically the recovery. And one of the good things about this is if you're running, this is the thing that would have got people out of a lot of trouble. So if we're here, a lot of people with their projects were here, and then we suddenly drop the part midway through a cycle, and then we're kind of locked up and can't finish. This is a great way to be able to just be able to say, okay, my cycle is now messed up. What do? I am hoping I can just hold this button down. See, and here's the thing I want to be able to do. I want to be able to just hit that button and bring it back home. So why is that not returning right now? Let's look at that. It'll only return if the gripper is open. So it should be gripper open, or if I don't have a part. So this is basically how we get out of situations like this. And again, the gripper should now open as well. I'm going to guess that's the same situation there. We should be able to do this on the raise as well. Okay, so there we go. So that is all home. Okay, that is our all home logic. Part counting and cycle time. So let's look at the cycle time logic. This is under a file called, what is this? Timing and counting. So we have 3 lines of logic here done for you already. So we're going to have to add to this. So this is using the one shot, which was explained this week. So we have somewhere to add logic for what starts your time, what stops your time, and then this is our running cycle timer. So what is going to define our start and stop here? So we want to pick one event. We're trying to do a part-to-part cycle time. So the way that we can do this one, for this, if we time the drop of the part, so if we use part present at exit conveyor as our what's going to stop our time, and just have this running all the time as the start, you'll see this will actually work quite well. Now the one extra line we need to put in here is we actually want to capture this. So if we think about how this one shot works, and actually I'm not going to run this, I'm going to run this in auto mode instead. Let's say if we are in auto, so actually running an auto cycle. So it has to happen between here and the actual timer, because when this hits the timer, it actually resets this. We want to be in a line in between these two where we're actually going to grab the accumulated value of the timer and move it to something. So let's actually do that here. And this could be done in one step, but we're actually going to grab it. I'm just going to do it as a move so you can actually see it. So let's say when we actually hit that cycle time stop, we will actually perform this move. So we're going to grab the accumulated value of this timer and move this to a register that I'm going to call cycle time capture. And let's make this a float, or sorry, a real. So this is basically what the value is at the instant that the timer stops. So we will grab it and capture it and store it here. And then we can move it somewhere else. So now we'll just do a move. And actually, yeah, we'll do a divide. It's asking us to put it in seconds. So we'll divide that by 1,000. So that's going to be in thousandths of a second. So we'll take that and move it to, it's actually an output register for this. Cycle time display. That's that register. So you'll be able to see this running. So you can see that value counts up, and then right before this resets the timer, it will grab the latest accumulated value, move it into here on a one-shot pulse, and then that gets updated each cycle. So you can see that's basically 5.746 seconds, 5.567 seconds, 5.69. Now we're able to divide here and round it off onto something we can actually display on this. This would probably actually be better displayed as a reel. But that is what we are displaying here. So you can see that here. Okay, and the last thing we want to do is count parts. You know how to count parts, so I will leave that part up to you. I'm not going to show you how to do it. You can figure out a way to count parts and then have them display on here, and then have them reset with that button as well. But that should be all of the logic we are trying to accomplish here. The one other thing we're trying to do is show a dry cycle logic as well. So I will show that demonstrated. Dry cycle is basically running without parts. So we have a bit down here called dry cycle. If we turn that on, we want to be able to run without any parts. So a bunch of our logic right now is dependent upon a part being present. So you can see that we have things right now with part present in the grippers, stuff like that. We want to be able to fake those things from happening. So we want to create some logic that gets around that instead. So the way that we would do that, so basically we could do a couple things with some I'm just going to create some tags here. I'm going to create a bit here called dry cycle part at entry. I'll make a bit for that. And let's basically turn this on. Let's have a timer turn that on. So let's say every 5 seconds that goes by, we'll turn that on. Every 10 seconds. Every 5 seconds. So every 5 seconds, this bit's going to come on. We will latch it on, and then we will unlatch it when we have when we are so PNP X is advanced, is return complete. So what indicates we would have picked it up? Raise complete. And close complete. We'll have that indicate that the part has been picked up and is gone. So we'll do that. So that basically means we picked it up. And now we also need a bit that says that we have it in the gripper. So let's turn one on here that says return lower and closed. That'll turn on a bit that says dry cycle PP gripper. We could do that, indicating that there's a part in the gripper. And then when we are advanced, lowered, and open, we will unlatch that. So that's going to indicate that we have dropped the part. Okay, so anywhere now where we have logic that is dependent, so you can see how this is basically indicating that we have a part in the gripper. Alright, so anywhere we have logic that is dependent on parts being present, we are going to make an alternate rung with that. So let's start over here with the advanced. So here we're saying that there is a part present, or a gripper part present. Let's only do this for auto. So here we are going to branch around this, and we are saying gripper part present. So this is if we are not in dry cycle. So modes dot dry cycle. So not in dry cycle, we're just going to run normally like that. If we are in dry cycle, instead of using that bit, there, we will use PP gripper. Should something fail here? Okay, back to this. That way I have a gripper, a return gripper not present. So we'll say we are not in dry cycle. That is our condition. I'll look for that on the Z. We are looking here. Again, we're looking for gripper present. And on the lower, we are looking for not dry cycle, not dry cycle, and dry cycle, dry cycle. Okay, and on the gripper, dry cycle, gripper, do that.
down here, and that only depends on entry. Modes.dry cycle and modes.dry cycle. This should run, hopefully. Let's drop this in. So regular operation should just keep on running the same way. So right now, if we are not in dry cycle mode, it'll just keep on cycling as it was. Just like that. If we do put it in dry cycle mode, what should happen is it should now stop emitting parts, but should still keep running just like it was. So we are going to toggle this bit. I'm going to toggle this bit by doing a right click and then hitting this here, toggle bit, or you can just control T on a bit, but I am basically going to do this. So you'll see now we do not have parts coming out anymore. But what this should now be doing is giving it a fake simulated part. That now replaces all of our part present signals in here. And it does keep on running. So if we wanted to test a machine without having to run parts through it, this is basically the method we would use for doing that. Being able to do this. This is called dry cycling a machine. Dry meaning running without parts. Okay, so that is all of our logic for this week. That is the complete lab. You'll notice my cycle timer no longer works anymore. That is one other place that I should have changed this, because this cycle time is dependent on that as well. I should also put that in here. I don't have anything for exit conveyor. I didn't make anything for that. So the cycle timer is not running in dry cycle. So let me switch it back over. I'm going to deactivate that. We're going to start emitting parts again. Ah, it didn't switch over cleanly. I'm just going to home return it. And there we go. All right, so that is the pick and place. So, complete machine.